The real sort of win is when you're starting to graph things. So let's have a look at the command that lets you do that. mplotqueries mongod.log. We'll just run that without any arguments whatsoever, so we'll leave everything to be the defaults and see what happens. And what we've got here is a graph of the operations, and again done by the namespace over here, so database.collection. And we can see that the further up these are, the longer they're taking. So this is the duration of the operation, scatter plotted, time on the x-axis, amount of time taken by the individual operation to complete on the y-axis. And it's a little bit hard to read this actually, because the absolute values are so far apart for this value versus the ones down here. So if we flick back very quickly, there's some keyboard shortcuts printed out for you here. So these are interactive graphs. You can actually do things with them. So what we're going to do is we are going to switch on the log. We're going to toggle the log y-axis to make this a bit more visible. So let's do that. There we go. So now we've got a logarithmic scale over here. This sort of brings everything back together into a more visible pattern. And you can see there are most definitely patterns here. You know, there seem to be events where the operations on that, you know, green square server-side $$ command are taking an awful lot of time. So you might want to know what those are. Let's take some of the worst performing ones here and click on one of the dots, and what happens is back here in our server console we get to see what made up those dots. So in this case the commands that are being run are getLastError. It's a little bit tough to see them, so let's scroll over a little bit more. And they're getLastError wMajority. Okay, so that's interesting. So these are commands. So this is an older log file, most likely to 2 if memory serves. You won't see these now. Things have changed a little bit in terms of how this works, but the logic is still there. getLastError1 wMajority. So for some reason, majority operations were taking a very, very long time to complete. So that might make us think, well, for a majority operation to complete, you have to have 2 out of 3, 3 out of 5 replica set members up and working. So maybe there was something going on with some of the replica set members. Let's see if we can find out more. So in order to see if we can see what's going on in terms of the replica set state, now we're only looking at the MongoD logs for a single node here, so we may not get all the information, but let's have a look and see what replica set state tells us. This is --type rs state is what we're passing in here. Now, having run the replica set state, rs state type of analysis, we get a very different graph. First of all the scatter plots are gone, and what we've got is a series of lines here. And Thomas has attempted to make the colors of these lines roughly match the color of the lines that you'll see in MMS, just for consistency purposes, so we don't have to relearn every time. So what we've got here, this yellow line is a state transition to secondary. Further up, we've got a red line, which is a restart, or down, in other words, it came back up afterwards. Recovering, startup 2, there's a primary in there, it's sort of the pink line here. You've got another recovering, another restart, etc., etc. So you can actually see the state transitions. This node most definitely did bounce around between being a secondary, primary, being restarted, etc. So an eventful time here, to say the least. And that's great. So we've got 2 separate graphs, which is good, but what we'd really like is a way to overlay the 2 so that we can correlate the events in one with the query times in the other. And that capability is also included in mplotqueries. So I run the same command that we did at the start to generate our scatter plot, and this time passed in --overlay. So it doesn't actually display a graph. What it does is it creates an overlay, and the next time I run mplotqueries without the overlay command, what it will do is it will take anything that's in here that's been created, and they're cached, you can reset the cache and things like that, and overlay it on top of whatever I run next. So what I'll do next is I'll run the replica set state graph again. So this should give me our original one, our scatter plot, overlaid on top of our replica set state graph. And as you can see, that's been successful. A few of the colors have changed, but basically we have what we wanted. Again, we're going to switch to a logarithmic scale, so it's a little bit easier to see. Now, There's no state transitions for these lines here, for these events, if you like, here, which suggests that these are probably being caused by another node somewhere else. Don't forget that it may not be this node that's having the problem that's causing these events, because when we looked into them, they were all get last error W majority. So that could be other secondaries or the primary or whatever changing state, going down and causing these operations to take a long time to complete. However, over here it's fairly obvious that it's our node, or a combination of our node and another one, causing these problems over here. So if we go back to our handy dandy list of shortcuts, we see that we can move to zoom mode by pressing O. So we'll do that, and we'll just zoom in on these events. So let's zoom in again just to make it even more obvious. So there we go. Now we can clearly see that these operations are lining up with the transition to secondary. Right? So in other words, there weren't enough secondaries in the set until this switched to secondary to satisfy that W majority. So you've got cause and effect here, essentially, nicely lined up and illustrated. And that's very nice. So let's reset back to the original view here. Now you might have a much busier graph. You might have more problems actually seeing this if there was, a lot of noise here. So how would you just separate out those get last errors, right? How would you get them by themselves? Well, it turns out to be not too hard to do. First thing we're going to do is reset the overlay. So we're going to do overlay reset. Here we go. Okay. And this time we're going to actually combine two of our tricks here. We're going to grep out get last error from mongod.log, and we're going to pipe it into mplotqueries and set it as an overlay. We reset them here, and now we're going to create a new one that should just be those get last errors from mongod.log as an overlay graphed by mplotqueries. So let's do that. We have our new overlay. Perfect. So all we have to do now is do the same thing again. Regenerate our replica set state graph. And here you go again, and this time a much cleaner graph, not as much noise out here. We've really only got the state transitions and then the one namespace, server-side $command, which is where those get last errors are being run against. So if it had been too noisy, as in this particular case, it wasn't the case, so we were fine. But let's zoom in again, and then we're back to our sort of direct correlation between those long-running operations, the get last errors, and the secondary transitions, which is that yellow line. So that's just a quick run through some of the initial functionality of mtools and the way it can save you significant amounts of time when you're analyzing a lot of log files. You can also use it to combine log files. You can look at log files from more than one host. There's many other pieces of functionality here, and I just wanted to make sure that everyone here was aware of it. If you're doing a lot of analysis of log files, of events in MongoDB, it can be an invaluable tool to help you get there quickly. And then finally, just one more time, not an officially supported MongoDB product, but most definitely a highly recommended product.